Find the area of the region bounded by the following graphs. We have y equals x and y equals x squared minus 6. So if I were to draw just a little picture, okay, of what's going on here, y equals x squared minus 6, let's actually move u up because that's going to be probably the more important part. Y equals x squared minus 6 is just a regular old parabola shifted down 6 units, something like that. Okay, that's what u is. Y equals x is going to be a linear equation going through that. Oh boy, good job drawing a line by me. No one will ever know. Now, the function for finding the area bound by two graphs is going to be the integral with limits of integration a and b of f of x minus g of x dx. A and B are where these two lines intersect. So I have to find out where these two lines intersect. And then what I'm going to do is I'm going to take the upper graph, which appears to be the linear equation, and subtract out the lower graph, which appears to be the parabola. But first, like I said, we have to find out where they intersect. So I'm going to set these guys equal to each other. I'm going to have x equals x squared minus 6. Let's subtract x from both sides. 0 equals x squared minus x minus 6. Factor that out. X minus 3, x plus 2. And my zeros are going to be at positive 3 and negative 2. So those are going to be my limits of integration. I'll make the smaller one a, the larger one b, like so. And now we have enough ammunition to plug stuff in. So I have the integral from negative 2 to 3 of f of x, which we're calling the linear equation, x minus g of x, which is x cubed minus 6. Now, if you're like, what if I have that backwards? Then you're going to get the same exact number, but it's going to be negative, and you just have to realize, oh, since I got it backwards, the answer is going to be the opposite, so it's going to be a positive whatever. So if my answer is negative 50, the actual answer is positive 50. So let's go ahead and do this. Let's rewrite that out after distributing the negatives. So negative 2 and 3, x minus x squared plus 6 dx. And let's integrate that. So you have 1/2 x squared minus 1/3 x cubed plus 6x with limits at negative 2 and 3. Ugh. This is not going to be fun. All right. That's my song. 1/2 3 squared minus 1/3 3 cubed plus 6 times 3 minus 1/2 negative 2 squared minus 1/3 negative 2 cubed plus 6 times negative 2. We're going to use all this space because I have a feeling we're going to need it. All right, we've got 1/2 times 9 minus 1/3 times 27 plus 18 minus 1/2 times 4 minus 1/3 times negative 8 plus or minus 12, not plus or minus, just minus. It's not a quadratic formula. Oh, we have fun when we screw up. We got 9 over 2. We've got negative 1/3 of 27 is negative 9 plus 18 minus, we've got half of 4, which is 2. Negative 1/3 of negative 8 is positive 8/3 gross minus 12. That is going to be, let's kill birds with two stones. I'm leaving it. I'm not editing anything. A negative 9 plus 18 is going to be 9. So let's make that 18 over 2. Okay. What is that? Negative 10 plus 8 over 3. So let's make 8 over 3, 8 over 3, and negative 10 is going to be minus 30 over 3. Okay. See what I did there? That is going to be 27 over 2 minus negative 22 over 3, which is going to be, let me see, we got a double negative here, so I want to multiply the top and the bottom of this one by 3, so 27 times 3 is 70, nope, 81. So we got 81 over 6 plus 60, nope, 44 over 6, which ends up being 125 over 6. Does that simplify? No. So that's our guy. Whew. So yeah, that's what this whole region is. That whole region is whatever 125 over 6 is. So not pretty, but neither's your mama. Thanks for watching. Bye.